of all, thank you for coming here and providing me the opportunity to be here. And I welcome all guests, dignitaries on the dais, off the dais, to spend a Saturday evening for the technology day. Being the youngest of the panel has its own benefits because all the elderlies have set the tone for me. Now I don't have to talk that much about why I am doing it, for how much I am doing it, for any reason that what we are keeping here. So, let us, as the question paper was said, what the hints were given by Dr. Kakodkar sir also, some way path was being given by the other speakers as well. So I am coming up with my kind of a solution to that particular question paper. So we are, as IYNS Tech Solutions, we are as a youth-driven industry which we are trying to develop is India's first micro-nuclear reactor, that is indigenous micro-nuclear reactor. We are calling it SUK-M, which is Swayam Chalit Utkrantik Kendra, that is autonomous evolutionary nuclear fusion machine, and that in the micro format, so that is SOOKSHMA. Basically, I'll just cover up some of what my presentation will be, like our goals, what are we trying to achieve, the mission and vision what we have, some critical parts, the details about the micro reactor, about the deployment, about the development, the reasons what we are targeting, what particular questions, and then the project timeline, what we wish to achieve during this domain. So the first thing, as the sir said, that modern problems require modern solutions. So the current problem will require the next generation nuclear solution. So we are calling it as Indian Nuclear Program 2.0, which is primarily youth-led but industry-driven. Because youth and private industry will have to be all together to make this challenge or the dream come true. Along with that, not just being, the sir said that we should not just follow what we are getting from the outsides or the foreigners also. Why can't we lead in that particular domain? India has been have created marvelous records in the nuclear sector. Then why aren't we leading there in that domain also? So that is why indigenous and innovation, along with the development and growth of the nation, is what the target and what we want to achieve with this particular idea. So obviously, when we say that indigenous, the words like Make in India, Atmanirbhar, startup culture, and all are on the same basket when we talk about, which are currently more enthusiasm, which encourages more enthusiasm in the youth that yes, we can develop something of our own, some sources, some ideas, some in technology clubbed together with some support and some guidance from the more stalwarts in the field, then we can be developed. So basically, Make in India, as the sir said, that if we reduce the size of the reactor, then the number of the reactors in the domain will increase. So if we are placing a 1000 megawatt reactor in a domain, and if I say that I only want 10 megawatt, I'll have to place 100 reactors. So if I have to make 100 reactors, I have to have industry making it in a parallel sector. I'll have to have, so the couple of industries will not be sufficient for me, 2 to 3 industries who know how to make it. So now we have to expand our zone, that MSMEs or each and every major industries and majority of the industries in every sector should come up together to build it. So that way, the indigenization will require localization as well as support from the MSMEs to the large industries as well. Along with that, Atmanirbhar. So if I say today we build up 100 reactors, I'll need 100 operators, 100 skilled persons who will be working for that, 100 safeguard opportunities. So this is also increasing the domain of job creation as well as the skilled workforce, or what we are saying is the capacity building. That capacity building then has to be also indigenous. We cannot say that, so if I made a reactor, I have 100 reactors in place, but only few people running them, then it is again we'll be having an error in that format. So the capacity building for tomorrow should also start today. That is where the complete Atmanirbharta of the particular idea will come into picture. The outcome, definitely, if this we are able to achieve it, will be the technological reliance or energy self-reliance. Because if we are developing our own, then the security is in our hands, not someone dependent upon import or export in that manner. So the solution, one particular answer to that particular question of the today's question paper is the SOOKSHMA. Why are we are targeting 30 megawatt thermal or 10 megawatt electric power output? This number we had chosen because majority of the forging industries require somewhat heat closer to 30, 20 or 25 megawatt in that domain. And if you have to go about electricity, then a multiple of 10 megawatt electric will be a suitable one, so that multiply and a series of formation can be made. With this, refueling cycle definitely will affect, the range in the refueling cycle of 10 to 15 years will come from the intended application what we are trying to achieve. If you want a heat as an application, high heat can be drawn, the burn-up will be higher, it has to be refueled faster. Electricity, low heat, lower temperatures will be there, burn-up can be contained, and we can have a longer refueling time also. Then the part was, if you're making it small, then it should also reach each and every place, nooks and corners of India, and for every possible terrain, scenario, weather, everything. So then it has to be in a smaller manner where one such vehicle which can go about is the train connectivity and the rail transport. So road transport. So that connects our India to the every part, from the every nook and corner to the main streets and highways. So that the size can come from the same similar manner. It has to be contained within the domain. So, and then the part is the conceptual. So currently the design is in conceptual manner, and since we said that it has to cater to multiple solutions in one domain. Like if you want hydrogen, different product. If you want heat, a different setting needs to be made. If you want electricity, a different product needs to be made, or a different setting needs to be considered. So along with that particular part, thus the structural material, the coolant, the piping needs to be changed. So, currently we are looking for 3 different ideas for 3 particular applications. We are looking for fluoride-based lithium, beryllium options, some carbide options are there. We are looking for the coolant, since it's a molten reactor in its own format. So, it provides a coolant in itself. But if you require something else, we're looking for that too. And we are looking for one of the idea which is coming up now is using of, heat pipes. Most efficient of one of the transferring the heat energy there. So we are able to maximize the energy output what can be done in this manner. So completely indigenous design. Here I want the fuel what we are trying to use is the fluoride-based molten salts, which will actually cater. The size will remain the same. What we are trying to do is the size of the reactor will remain the same. But the settings or the the burn-up or the modifications will be based upon the intended application model. Along with that, this will also provide an opportunity for thorium utilization. So I think the sir has critically explained why thorium becomes a prominent fuel for India. Along with that, thorium also has particularly characteristics like the non-proliferation. It reduces waste. The spent fuel cycle is much more easier. So in a similar manner, this as restricted the preliminary calculations suggest that the core diameter will be just close to 2 meters. And the major part with what we are trying, and why the industry in the major part steps in, is the standardized modular supply chain. I'll explain what do I mean by standardized. Currently, reactors have a parts which are only specified, they are not standardized or they are specified for the particular reactor design. That makes them, a unique part which has to be created by which has rights or royalty to only one company. So if I have to make it, it is much more expensive than that. So this rapid supply chain system can be created, which will be able to multiply nuclear in a stipulated amount of time. What we say, what we are targeting as the Amrut Kal. So for this particular like kind of a pathway will ensure the drastic reduction of carbon footprints down the line. So the why, and since the size is a very we have kept it very small, it provides us very much of options to deploy. Like sir said, the coal fields can be retired coal plants can be replaced with this particular kind of also. Reactor size also. So brownfield sites, remote locations where currently, since it is having 10 to 15 years of long fueling life, you can place one those remote locations will have a power for that longer time of a domain. Captive power usage, be it heat, be it electricity, be it hydrogen production, the other applications that can be done. Isolated areas, islands, like Lakshadweep today also we power it by DG generator sets. What if I put just one reactor? That would take care of the emissions, that would take care of the the power there, and that too without that is basically uninterrupted power supply for a longer period of time.